Is the rational function f of x equals the quantity x squared plus 3x minus 40 divided by the quantity x plus 8 continuous at x equals negative 8? Notice if we try to determine f of negative 8, in the denominator we have negative 8 plus 8, which is 0, and division by 0 is undefined, which means f of x has discontinuity at x equals negative 8, and therefore is not always continuous. So we can go ahead and answer this first question. No, f of x is not a continuous function. It does have discontinuity at x equals negative 8. And now let's review removable and non-removable discontinuity. If f of x can be made continuous by appropriately redefining or defining f of c at x equals c, then f of x has removable discontinuity, which means if a function has a hole, it has removable discontinuity. For rational functions, removable discontinuity occurs at the zeros of the common factors between the numerator and denominator. For non-removable discontinuity, f of x cannot be made continuous by redefining f of c. For rational functions, this is when we have vertical asymptotes, and the vertical asymptotes occur at the zeros of the denominator that are not zeros of the numerator. So now let's determine whether we have removable or non-removable discontinuity at x equals negative 8. To do this, we will go ahead and factor the numerator and denominator. In this case, the denominator does not factor. So we'll go ahead and try to factor the numerator. If it does factor, it'll factor into two binomial factors. The factors of x squared are x and x. For the second positions, we want the factors of negative 40 that add to positive 3. Well, positive 8 times negative 5 is equal to negative 40, and the sum of 8 and negative 5 is positive 3, which indicates we have a factor of x plus 8 and a factor of x minus 5. Notice f of x does have a common factor of x plus 8 between the numerator and denominator, and negative 8 is a 0 of x plus 8. This indicates the graph of f of x has a hole at x equals negative 8, not a vertical asymptote, which also means f of x has removable discontinuity at x equals negative 8. It does not have a non-removable discontinuity. Also notice if we were to simplify this function by simplifying out the x plus 8s, we would have f of x equals x minus 5. This indicates the graph of the original function f of x is the same as a line y equals negative 5, except the line must have a hole at x equals negative 8. And we'll take a look at this graph in just a moment. But again, because x equals negative 8 is a 0 of the common factor of x plus 8 between the numerator and denominator, the graph has a hole at x equals negative 8, not a vertical asymptote, which means it has removable discontinuity at x equals negative 8. So looking below, we want to select the true statement. We know the first statement is not true, that the function is continuous. The second statement is the function has a removable discontinuity at x equals negative 8, which is true. The third statement, the function does not have a removable discontinuity at x equals negative 8, and that is false. And now let's look at the graph of f of x. One of the issues with using technology to graph functions is most graphing calculators are not going to graph holes in functions. Notice when I graphed the original function f of x in Desmos, it looks like a solid line, but that's not really accurate. We actually have to plot the hole manually by plotting the point negative 8 comma negative 13 as an open point. If you're wondering how I got the negative 13, remember when we simplified the function, we got y equals x minus 5, and notice if we substitute negative 8 for x in the line, we get negative 8 minus 5, which is negative 13. So now we have an accurate graph of the original function, but just to show you the graph is the same as a line y equals negative 5, I'm going to go ahead and turn off the open point, graph the blue line, and you can see the blue line and the red function without the hole are exactly the same. But again, for an accurate graph, we do have to plot the hole as a separate entry. This is the accurate graph of f of x, and this hole does emphasize that we have removable discontinuity. I hope you found this helpful.